Hey physicists, what's the crack? So today we're going to do another paper-free section B astrophysics question. Okay, so this is the optional topic. So this one here is about the HR diagram, and what the question for 1 mark wanted us to do was to label the absolute magnitude scale. Okay, so the way I remembered it is the absolute magnitude scale. We remember that Hipparchus told us from 1 to 6 is what he could observe with the naked eye on Earth. Okay, so those are the positive numbers. So the way I remembered it is the positive numbers are always the bigger numbers. So the bigger number at the bottom is the positive 15, and it goes from positive 15 up to negative 10, okay? And then you always want to label on roughly where positive 5 is, where 0 is, and then where negative 5 is. Okay, so the key thing to remember here is absolute magnitude. The more negative the numbers are, the brighter the star is, okay? Okay, so first one's done. Next one said label with an S the position of the sun. So you need to remember the sun is a G-class star, and it's got an absolute magnitude of 5. Okay, so what you need to find is number 5, absolute magnitude, go across, and it's a G-class star. Okay, so what I have to remember again is my OB, fine girl, kiss me. So my G-class stars are roughly around 6,000 degrees Celsius. So you find roughly where 6,000 is, you go up, go along +5, and plot an S where my sun is. Okay, so my sun is a G5 star. Okay, so my sun makes sense, is on my main sequence. Okay, next one for 2 marks was draw a line on the HR diagram to show the evolution of a star similar to the sun. Okay, so the sun we know is on the main sequence. Its evolution we're going to do from birth. Okay, so when a star is born, it starts in nebula, that cloud of gas and dust. Then that collapses in itself to form a protostar. So your protostar is over here. Makes sense? It's going to be cooler than my sun, and it's going to be an absolute magnitude a bit less. Okay, so it's going to go from a protostar into my main sequence. After it goes into your main sequence, once it stops burning its hydrogen and stops fusion, what's going to do, it's going to expand slightly from a red giant. So we're going to go up into our red giant. And then after our red giant, what it's going to do is going to collapse in on itself to form a white dwarf. So our sun then is going to form a white dwarf. And after a really long time, that's going to cool to form a black dwarf because we'll not see it any longer. Okay, so that's my 2 marks then. Finish off my HR diagram. So that's grand.